All life on Earth is based on carbon. Plants are 46% carbon. Bacteria are 50% carbon by weight. In fact, carbon is the most essential nutrient required by plants and microbes. There are several key challenges associated with carbon utilization. Let's review the role and function of carbon for plants and soils. Plants obtain carbon through photosynthesis. This process requires the plant to spend a great deal of energy processing carbon. This carbon is essential for plant growth and vigor. Microbes also need carbon, which they obtain by decomposing organic matter found in soil, or by breaking down large carbon molecules added to the soil. This process of breaking down organic matter and other soil-applied carbon also requires a great deal of energy and time. In addition, most forms of applied carbon are also too large to be absorbed foliarly or by soil microbes. Plants require many other nutrients for growth and proper development. Most nutrients are tied up in the soil. Much of the nutrients that are applied to plants, whether by foliar or soil application, never make it into the plant, let alone the produce. So let's review some of the challenges we've discussed so far. Number 1. Plants and microbes expend a great deal of energy and time processing carbon. Number 2. Most natural forms of carbon are too large and complex for easy absorption. Number 3. Many soil-applied nutrients are not effectively taken up into the plant or remain tied up in the soil. There is a solution. Microcarbon technology is a concentrated blend of extremely small organic carbon and oxygen-rich molecules. These molecules act as a source of carbon and provide an ultra-efficient vehicle to move nutrients and other molecules into the plant through the soil and/or leaves. So what makes MCT so unique? Well, it is the molecule size that makes the difference. Humic acids are very complex and contain thousands of carbon rings. Fulvic acids contain hundreds of carbon rings. MCT contains fewer than 10 carbon rings. Functional groups allow MCT to complex with positive and negative charged nutrients. This makes MCT the perfect nutrient carrier. MCT is an effective carbon source and nutrient carrier that is readily available. MCT easily complexes with nutrients, protects them from losses, and improves nutrient uptake. The significantly smaller particle size allows both carbon and nutrient to enter the plant at a far higher rate. MCT enters the plant through foliar or soil application and is immediately available for use by the plant. Additionally, MCT acts as a magnet, attracting nutrient particles from the soil. When MCT enters the root hair, it brings with it the attached nutrients on the functional groups. Microbes also take in carbon and nutrients at a more efficient rate with MCT, allowing beneficial microbes to reproduce more quickly and to be more active. This results in a healthier soil. With carbon and nutrients immediately available, plants and microbes can flourish. So to review, number 1, MCT is readily available and does not need additional processing within the soil. Number 2, MCT's carbon molecule size and simple structure allow it to be easily assimilated, either through both foliar and soil application. When complexed with MCT, soil-applied nutrients avoid tie-up and remain available. MCT also frees up additional nutrients in the soil. All plants and soil microbes need carbon and many other nutrients. MCT is the solution for providing the carbon and nutrients that plants need, exactly when and where they are needed.